Hello students, today we'll be solving the IB Math A HL May 2024 paper 2 time zone 2 question number 11. You will be getting the other solved questions of this paper and of the other papers in form of playlists on my channel NS Online Math Tutoring Classes. You will also be getting playlists where the solved past paper questions will be available based on their topics. I am Nilanjana Sanyal. I am an online IB Math A HL level tutor. In case you want to join my classes, please contact me for more details. My phone number and my website address are displayed at the bottom of the screen. So without any further delay, let us start solving this question number 11. The maximum mark is 17. It says a rotating sprinkler is at a fixed point S over here. It waters all points inside and on a circle of radius 20 meters. Point S is 14 meters from the edge of a path which runs in a north-south direction. The edge of the path intersects the circle at points A and B. This information is shown in the following diagram. This is the north. So part A's question is show that AB equal to 28.57. Correct to 4 significant figures. It is containing 3 marks. Okay, so fine. So it is AB. Okay, and this is a right triangle that has been drawn. Maybe, not maybe, it is definitely the midpoint because this is a line joining, not joining, it is a perpendicular drawn from the center of the circle to a chord. AB is a chord. So if you draw a perpendicular, drop a perpendicular from the center of a circle to a chord, it bisects the chord. So this is the midpoint of this AB. Okay, so it is, and now if we can find the measurement of this EM, we will be doubling it to get the measurement of AB. So what will be the measurement of EM if I take this angle to be equal to theta? Or else you can use the Pythagoras theorem also. Let me use the Pythagoras theorem. So it will be EM square equal to 20 square minus 14 square. Okay, so EM square is equal to 20 square is 400 and I know 14 square is 196. You can use your calculator definitely. So this is equal to 400 minus 196. Enter 204. Okay. So therefore AM is equal to square root of 204. I am not taking plus minus because the distance, the length cannot be a negative number. So it will be, let me just write EB because I need EB. So therefore EB equal to 2 AM is equal to 2 times square root of 204. Okay. So therefore AB equal to 2 times square root of 204. Is 28.565. So 28.5657, let me write. So 28.5657. So therefore AB is equal to 28.57 meters. It should be meters, definitely. Correct to 4 significant figures. Okay. Fine. We have completed answering this part A. the sprinkler rotates at a constant rate of 1 revolution, that means 360 degree or 2 pi radians. The central angle will be 2 pi radians every 16 seconds. I am talking about the radians because this is in radians. Subpart B is saying show that the sprinkler rotates through an angle of pi over 8 radians in 1 second. Okay, it is just the unitary method that you have learnt in smaller classes. So it will be 16 seconds needed. You don't have to write these sentences for just a single mark. I know you will not be writing and it is not required. I am just writing these for the purpose of explanation. 16 seconds needed to cover an angle of 2 pi. If I don't write the units, it will be taken as radians. So cover an angle of 2 pi. Okay. Therefore, in 1 second, the angle covered will be equal to 1 over 16 times 2 pi equal to pi over 8 radians. Because they have written radians, I'm writing radians, but it is actually not required. Okay. Shown. Let t seconds be the time that this AB is watered in each revolution. Find the value of t. Okay. So for that, let me draw this line also. SB. So this is an isosceles triangle SAB. So this is also theta. Okay. So we have to find the angle theta, value of the angle theta, because we know pi over 8 radians is, if the angle is pi over 8 radians, the time taken is 1 second for watering that part. Okay, so I have to find the value of theta and I have to double it so that I get the value of 2 theta. And then I'll be finding the time. So let me write the B part over here. I have to find the angle theta. So angle theta will be, if I take cos theta, because I'm not taking sin theta, I can take sin theta, but this AM will be an approximation. Okay, I have to take some digits, but these are correct values, so I prefer to take cos theta rather than tan theta, sin theta or tan theta also. So cos theta is equal to 14 over 20, equal to 7 over 10 or 0.7. Therefore, theta equal to cos inverse 0.7. Let us find the value. First of all, you have to check whether your angle is in radians or in degrees. Mine is in radians, so in case your angle is set to degrees, change it to radians. If you just click over here, it gets changed to degrees. You see, again you click, it gets changed to radians. Okay, so cos inverse, this is cos inverse of 0.7. I can take 2 theta. Okay, let me first of all get theta. This is the theta value and I need 2 theta. So 2 times answer. Okay, so therefore 2 theta is equal to 2 times cos inverse of 0.7 equal to, it is 1.590797. 1.5907976. Okay, I can take. Okay, so 1.5907976. Okay, so this is the 2 theta angle, this whole thing. And we know that pi over 8 radians is watered, not the angle, the proportional portion is watered in the corresponding portion rather is watered in 1 second. So in how many seconds will the portion corresponding to this central angle be watered? That is the simple logic that we have to apply for this question. Okay, and that time will be the t seconds. Okay, so we will be saying pi over 8 when pi over 8 is the central angle. Time needed is 1 second. Okay, therefore, when 1.5907976 is the central angle, time needed is 1.5907976 divided by pi over 8 into 1 multiplied by 1. So this will be equal to t seconds. Let us find what is this equal to. Okay. So, and it is the answer divided by pi over 8. It is 4.05093 and all. I can write this as 4.05 seconds, correct to 3 significant figures. Okay. So, this is equal to t seconds. Okay. Therefore, t is equal to 4.05 seconds. Correct to 3 significant figures. Okay. Sorry, this is subpart C, so I have marked it incorrectly. So this will be subpart C. Okay. So consider one clockwise revolution of the sprinkler. At t equal to 0, the water crosses the edge of the path at E. At time t seconds, the water crosses the edge of the path at a movable point D, which is a distance d meters south of the point E. And let alpha be angle EST and beta be angle SAB. Okay, SAB or SAD, whatever it is. And alpha and beta are measured in radians. This information is shown in the following diagram. The subpart D's question is write down an expression for alpha in terms of t. It is containing just a single mark. So when subpart D, when time is 1 second, central angle is equal to pi over 8 radians. We have seen that. Therefore, when time is t seconds, okay, because when time equal to t second, the sprinkler is at this position. So, when time is equal to t seconds, central angle is equal to pi t over 8 or pi over 8 times t seconds, radians. Okay. So, therefore, alpha is 1 second pi over 8 radians. So, t seconds pi over 8 times t radians. So, alpha equal to pi over 8 t radians. Okay. It is known that beta equal to 0.7754 radians, correct to 4 significant figures. So, but each question is fine by using the sine rule in triangle ASD. Show that the distance d at time t can be modeled by this expression. Okay, we have to use the sine rule, they have said. And we need the d. So, for this, you see d, this one, AD is opposite to this angle alpha. And we know alpha to be equal to pi t over 8 because we are seeing that we have the pi t over 8. We need this, okay? So, therefore, and we need d. So, this is one of the sides that we have to take. Opposite to that is this angle alpha. We will be taking this, okay? And which can be the other side. I can take this because beta is there. I can take this side as d. But I do not know the measurement, the length of this side is d. In that case, I have to, yes, I know the AM. AM was equal to most probably square root of 204. So, and this is d. So, this part, this was m. So, this BM will be square root of 204 minus d. So, this is known, this is known. I can get the length of SD. I can do, definitely I can do that. But I am seeing that I have this 20. Is this 20 the same 20? Let us see. Let us see. I don't know, but I am trying to use this side because I am seeing this number 20. Okay, instead of going for this, trying to get the length of SD, I am using this 20. But I know that this length, this angle is not known, but anyway, I can find this angle. This will be what? 180 or pi radians minus the sum total of alpha plus beta. Okay, so I'll be expressing this angle in that way. So, from applying the sine rule in triangle ASD, we have it is ED over sine alpha equal to SA or AS, whatever I call this side, and over sine, this is angle SDA. Okay, so therefore AD is D over sine alpha is pi t over 8 equal to AS is 20 over sine angle SDA. And what is angle SDA? It is pi minus alpha plus beta. Okay. So, therefore, d of t seconds, you come to that point d after t seconds. So, they have written d of t equal to 20. You see, this 20 is this 20, the AS length. 20 sine, I'm multiplying both sides with sine pi t over 8. So, sine pi t over 8 divided by sine of pi minus beta and minus alpha equal to d of t 20 sine pi t over 8 divided by sine. I have taken pi minus beta because I know the value of beta. It is given. And I am seeing, I know alpha is pi t over 8. So minus alpha minus pi t over 8. This will be just substituting the value of alpha. I'll be getting this part. But this will be obtained most probably by doing this subtraction. Okay. So pi minus 0.7754 minus pi t over 8. So this is equal to, now I will be using my calculator. This is paper 2. I have my calculator. Over sine. Let us see, what do I get? It is pi minus 0.7754. It is 2.366. Okay. So before that, I have to write pi minus, this is 2.36619. Let me write 2.36619. It is pi minus beta equal to, or pi minus 0.7754 equal to 2.37, correct, to three significant figures. Okay. So this is 2.37 minus pi t over 8. So this is what we have to show. Shown. Okay. A turtle walks south along the edge of the path. At time t seconds, the turtle's distance g meters south of OE can be modeled by g of t equal to 0.05 t squared plus 1.1 t plus 18, where t is greater than or equal to 0. So, but F's question is at t equal to 0, state how far south the turtle is from E. So, g is the distance where the turtle is situated south of E. So, F at t equal to 0, so the distance will be g of 0 equal to 0.05 times 0 square. You do not have to write so many things for 1 mark. I'm just showing it. How are you getting this value? The answer that I'll be writing, I'm just showing that. Okay. Equal to 18 meters. Okay. So, therefore, at t equal to 0, the turtle is 18 meters south of E. Okay. Let W represent the distance between the turtle and the point D at time t seconds. Support G it is containing 2 further support. I is use the expressions for G of t and D of t to write down an expression for W. W is the distance between these two in terms of t. Now the turtle can be over here, which is moving towards the south. It can be over here. Then this portion will be g of t, and this whole thing is d of t. Or this turtle can be somewhere over here also. Then this, maybe this is the t. Then this et will be equal to g of t. So if the turtle is over here, g of t is less than d of t. If the turtle is over here, g of t is more than d of t. So we have to take the difference, okay? Distance between these two, so it has to be the difference between these two. And we do not know which one is bigger, so we will be taking the absolute value, because the distance can never be a negative number, okay? Because we are not sure of which one is the bigger one. So we will be using the absolute value notation. So W is equal to the absolute value of g of t minus d of t. And the d of t was this one, okay? So this is W equal to, don't keep it this way, you have to write the expressions. 0.05 t square plus 1.1 t plus 18 minus 20 sine pi t over 8 divided by sine 2.37 minus pi t over 8. Okay. Okay. So this is the W expression. We have answered the subpart I. Hence, find, hence means we will be using this one. Find when and where on the path the water first reaches the turtle. Okay, and we know that the water crosses at t seconds. It is at t seconds. So the water crosses the movable point D. That we know. The question said that. Okay, so water crosses this movable point D at t seconds. So the turtle will be getting the water if the turtle is at d seconds, is at point D rather, sorry. Okay, so if the turtle is at point D, then g of t will be equal to d of t, so the W has to be equal to 0. Okay, so at t seconds, water crosses the point D. So the turtle will be getting water if it is at point D. Okay, so if, therefore, g of t is equal to d of t. D of t is what? The distance between this movable point D and A. And g of t is what? The distance between the turtle and the point A. So g of t has to be equal to d of t. So W should be equal to 0, because W is g of t minus d of t. Therefore, W equal to 0.05 t square plus 1.1 t plus 18 minus 20 sine pi t over 8 divided by sine 2.37 minus pi t over 8 equal to 0. Okay. And now we have to use the calculator to find the value of t. So I can use the nsolve, let's see, algebra and numerical solve, and it is the absolute value. Okay, and 0.05 times, I can write t square plus 1.1 times t plus 18 minus, it is, I need this thing, it is 20 times sine of pi t over 8. So again this pi times t over 8, and it is mm, sine 2.37 minus pi t over 8. Pi times t over 8. Okay, and this will be equal to, this is equal to 0. And comma, I have to declare the variable, it is t, and I move out. T should be greater than 0. Let me say that also. I don't know how many values will be there for t. So let me give the condition. T is greater than 0. Let's see what happens. Okay, it is 3.3488. So, or I need where also. Okay, so first of all, let me take more number of digits. So 3.3488 I'm taking. 3.3488. So therefore, using GDC, T is equal to 3.3488 seconds, or T is equal to 3.35 seconds. Correct to three significant figures. And when, where, so where is G of T? G of T, so G of T 3.3488 equal to 0.05 times 3.3488 square plus 1.1 times 3.3488 plus 18 equal to, okay, so I can take the answer 0.05 times answer square plus 1.1 times answer plus 18. It is 22.24 and all. So it is 22.2 meters I can take. Okay. 22.2 meters. correct to 3 significant figures. Okay, I'm just, yeah, I'm doing this also for the g of t. And now finally I'm writing the final statement. The turtle is 22.2 meters south of A at 3.35 seconds. When water reaches it. Okay. So this is all for this question. We have solved this question number 11 completely. Thank you for staying with me till the end. Please like and share this video in case you have liked my explanation, and please do not forget to subscribe to my YouTube channel. It will be motivating me, it will be helping me a lot because it will be increasing my videos reach. You will not only be helping me, you will be helping other students as well because the YouTube will be showing my video to more number of students. We meet again very soon in our next session. We'll be solving the last question of this paper. Till then, bye.